Hey everybody, thanks for clicking on this video. Today we're going to be looking at finding vertical asymptotes from function equations. If you want to follow along, the links to the companion worksheet, you can scroll down to the comments above the comments section and you can find that link. Also, if you want to see more videos like this, click that subscribe button so you can stay up to date on all the videos that we have coming out from the channel. So when we deal with vertical asymptotes, remember, we're talking about rational functions, which means all of these functions are expressed as a fraction. Now, when it comes to finding vertical asymptotes, what we're looking for is what are the values of x that make the denominator 0? And it's just the denominator. And that's going to become important in a second, you'll see. So in a sense, what we have here is we want to set this denominator equal to 0. X squared minus x minus 2 is equal to 0. Okay, well this is a quadratic, and thankfully this one we can factor. We can factor it into x minus 2 times x plus 1 equals 0. So this times this equals 0. So that means when we multiply two things and get 0, that means either this is 0 or this is 0. So we'll set this equal to 0. So that means x equals 2. Or we set this equal to 0, which means x equals negative 1. So that means this function has two vertical asymptotes at x equals negative 2 and x equals negative 1, because those two numbers will make the denominator only equal to 0. So for number 2, same thing. We're going to focus on x squared minus 9. And so we set x squared minus 9 equal to 0. This is a difference of squares, so we can factor that. We can factor that into x minus 3 times x plus 3 equals 0. So again, since they're factored, we set each factor equal to 0. And so that means x equals 3 or x equals negative 3. So this function also has two vertical asymptotes, because these two numbers will make the denominator 0 but will not make the numerator 0. For number 3, here we focus on this. 2x squared plus 1 equals 0. Now this one won't factor. So if we try to get x by itself, we could subtract 1. So 2x squared equals negative 1. We could divide by 2. So x squared equals negative 1/2. But at this point we have a problem, because whatever number we put in here, if we square it, should make it positive, but we have a negative. And so this is going to lead to a complex answer. And when we talk about vertical and horizontal asymptotes, we don't graph them in the complex plane. So yes, you could plug in a complex number to make the denominator 0, but when we talk about functions, as far as we're concerned right now, we're only dealing with functions where you plug in real numbers, not where you plug in complex numbers. So that means this one has no vertical asymptotes. Now the last one here, x squared minus x minus 6, we want to see when this is equal to 0. So this one we can factor into x minus 3 and x plus 2. So we can set each of these equal to 0. X minus 3 equals 0 and x plus 2 equals 0. So that means x equals 3 and x equals negative 2. So this looks like the first two, in that we would have two vertical asymptotes, but we actually only have one. It's this. So what's wrong with 3? Remember that I said that when you have a vertical asymptote, only the numerator is 0. In this case, if you plug in 3 into the top and the bottom, you get 0 on the top and on the bottom at the same time. Vertical asymptotes, that doesn't happen. So what's happening here is you're getting 0 on top and the bottom. And what that reveals isn't a vertical asymptote, but rather what we call a removable discontinuity. So this graph only has one vertical asymptote. Only -2 will produce a denominator of 0. Thanks for watching. If you liked the video, please give it a thumbs up. You have suggestions or problems you want to see worked out? Type a comment below. To support the channel, click the page to get the links to keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.